Good morning, students. In this class, we will see one more important topic, tangents and normals. In this class, we will find slope and equation of tangents and normals using derivatives. We know that slope of tangent of any curve. Suppose one curve is given, y equal to f of x. We want to find slope of its tangent at points say P, which is x naught, y naught. Okay, this is one tangent of this curve at point P. So its slope we want to find, and we know that slope of any tangent is derivative of that function. Okay, at that point. So we want to find slope tangent at point P. So derivative of y with respect to x at point P will be our slope of tangent. Our point is what? X naught y naught. So we can write here x naught y naught. Means after finding derivative of y, we will replace x by x naught, y by y naught. That will be our slope of tangent. Then slope of normal. What is normal? A line which is perpendicular to tangent. So this line tangent is at point P. So we draw a perpendicular at point P. Then this will be our normal. It is tangent. It is normal. Okay? A line perpendicular to tangent is called normal. And we know that if two lines are perpendicular, if L1 is perpendicular to L2, then what happens? Their slopes will have product -1. So if slope of tangent is dy by dx, suppose m1 is dy by dx, so m2 will be -1 upon dy by dx. Okay, so slope of normal at point P will be -1 upon dy by dx at x naught y naught, or you can write minus dx by dy at x naught y naught. This also we can find. Okay, this is slope of normal, slope of tangent. Then equation of tangent. Equation of tangent at point P will be, now to find equation of any line, what we need? One point and slope, or it's 2 points. So here we have one point x naught y naught, and slope also we are having. So equation of tangent, one using point slope form. What is point slope form? Y minus y1 is equal to m into x minus x1. This is the equation of line in point slope form. So equation of tangent at point P will be y minus y1, and y1 is our y naught is equal to m, that is dy by dx at x naught y naught into x minus x naught. X1 is x naught. So this is the equation of tangent at point P. Then equation of normal. Equation of normal at point P will be y minus y naught is equal to, slope of normal is -1 upon dy by dx at point x naught y naught into x minus x naught. So this is slope of equation of normal. So if one curve is given and we have to find its slope of tangent or slope of normal or equation of tangent normal at particular point. Okay? So if we want to find equation, then we need that point also. If we need tangent at one particular point, that point we need. So if point is given, then okay, otherwise we have to find that point also. This point of contact, this point is point of contact tangent and curve, that we have to find if it is not given. Okay? So now we'll see some questions based on tangents and normals. First you can note on this. Question is, find the slope of tangent to the curve y equal to x minus 1 upon x minus 2, where x is not equal to at point x equal to 10. Where x is 10, at that point we'll find slope of this tangent of the curve. So first, what we need for slope? We have y equal to x minus 1 upon x minus 2. So first we will find dy by dx. So differentiating with respect to x, we get dy by dx is equal to, use quotient rule. So denominator as it is, derivative of numerator 1 minus numerator as it is, derivative of denominator 1, and because both are having linear polynomial only, upon square of denominator. So it is equal to x minus 2 minus x plus 1, x minus 2 minus x plus 1 upon x minus 2 whole square, which is equal to x can cancel, minus 1 upon square of x minus 2. So this dy by dx minus 1 upon x minus 2 square. Now we need tangent at point, slope of tangent at point x equal to 10. So slope of tangent at x equal to 10 will be is value of dy by dx at x equal to 10, means minus 1 upon, replace x by 10, so minus 1 upon 8 square 64. So minus 1 upon 64 is the slope of tangent of this curve at point x equal to 10. Okay? This question can be asked in this manner: find the slope of tangent to the curve at point whose x coordinate is 10. Meaning is same, x coordinate is 10 means x equal to 10. Okay? So the question is, find the slope tangent of this curve at point whose x coordinate is something given, 5, 3, 2, 1, means same thing, x is given 5 or 10 or 3, that you can put after finding dy by dx. Okay? Now question is, find the slope of the normal to the curve x equal to a cos cube theta, y equal to a sin cube theta at theta equal to pi by 4. Now your curve is given in the parametric form. Now parametric equations are given for any curve. So we need its slope of normal at theta equal to pi by 4. So first we need dy by dx, that is slope of tangent. Slope of normal is minus 1 by dy by dx. So in case of finding slope of normal or tangent, we need dy by dx. So how to find dy by dx when parametric forms are given? Okay? So if you miss the class, then link will be given in the description box, you can see. So first, or you can see just here, we have x equal to a cos cube theta, then differentiating with respect to theta, our parameter is theta, so we get dx by d theta. It will be derivative of cos cube 3a cos square, and in the form of x cube, again different cos, we get minus sin theta. So derivative of x will be minus 3a cos square theta sin theta. Okay? Then y we have 3a sin cube theta. So differentiating y also with respect to theta, we get 3a, sorry, only a sin cube. We get 3a sin square theta into derivative sin again cos theta. Now dy by dx is dy by d theta upon dx by d theta. Okay? So dy by theta is 3a sin square theta cos theta upon dx by theta minus 3a cos square into sin. 3a 3 cancel out, 1 sin cancel out, 1 cos cancel out, so we get sin theta upon cos theta, and this is minus sin upon cos, we can say tan theta. So dy by dx is minus tan theta, or if we find value of dy by dx at theta equal to pi by 4 will be minus tan pi by 4, and tan pi by 4 is 1. So value of dy by dx at theta equal to pi by 4 is minus 1. So what is slope? Slope of the normal at theta equal to pi by 4 will be value of minus 1 upon dy by dx at theta equal to pi of 4 means minus 1 as it is, and its value we have minus 1 upon minus 1, that is 1. So slope of the normal at theta equal to pi of 4 is 1. Okay? So if parametric forms are given, then we have to find dy by dx first. How to find this? The process, find x, derivative of x and y is equal to the third parameter, third variable, that is parameter. Then divide derivative of y by derivative of x. That will give you derivative of y is equal to x. Okay? Then put whatever point is given, that will give you slope of the normal or slope of the tangent. Okay? Next question is, find a point on the curve y equal to x minus 2 square at which the tangent is parallel to the chord joining the points 2, 0 and 4, 4. We need a point on this curve at which if we draw tangent, then it will be parallel to line joining these 2 points. Okay? Suppose the curve is given and these are the 2 points 2, 0 and 4, 4. So in this curve where we will draw tangent so that it will be parallel to this line. So if we draw here tangent, then it will be parallel to this line. This point we need. Suppose this point is P. So point P we need at which we will draw tangent so that it will be parallel to line joining this points 2, 0 and 4, 4. So first, suppose let the point be P, say x1, y1 on the curve y equal to x minus 2 square, and this point P is on this curve. So this P is on this curve, it means it will satisfy this equation. So what we get? This point satisfies this curve P point. So we get y1, y replaced by y1 and x replaced by x1. Then we have, suppose this is one curve equation and 1, 2. So if this point P is on this curve, then we have an equation y1 equal to x1 minus 2 whole square. Okay? Now what we need? This tangent at point P is parallel to this line joining 2, 0 and 4, 4. So 2 lines are given parallel, and 2 lines are parallel, then their slopes will be equal. If 2 lines are parallel means their slopes are equal, and if slopes of 2 lines are equal, then they are parallel. So we need line parallel to this line, so we will find their slopes. So for finding slope of tangent of this curve, we differentiate 1 with respect to x. We differentiate y, first equation, with respect to x. Then we get dy by dx, that will be derivative of square of x minus 2 will be twice of x minus 2 and x square form. Again differentiating x minus 2 will get 1. So derivative of y is twice of x minus 2. So value of dy by dx or slope of the tangent at P x1 y1 will be, say, m1, which is value of dy by dx at x1 y1, that is twice of x1 minus 2. This slope of tangent of the curve at point P. Now we find slope of line joining A, say A point 20 and B 4, 4. The slope of line joining A 20 and B 4, 4 will be, say, m2. So slope of line joining 2 points is y2 minus y1. So y2 minus y1 means 4 minus 0 upon x2 minus x1 means 4 minus 2. So you get 4 by 2, that is 2. The slope of chord AB is 2. Now since tangent is parallel to this line, since your tangent is parallel to chord or line, Therefore, your m1 and m2 will be same. M1 is twice of x1 minus 2, m2 is 2. So 2 to cancel out, then x1 minus 2 equal to 0, 1. And we make mistake, student make mistake. They cancel out this 2, then we write that 0, but actually it will be 1. So x1 is 3. Many times students make this mistake. After cancelling, just they write 0 here. So x1 is 3. Now this x1 we put in this equation second. Then we get y1 equal to 3 minus 2 square, that is 1. So x1 is 3, y1 is 1. Means our required point is 3, 1. So if we draw tangent at point 3, 1 to this curve, then it will be parallel to this chord. The tangent at point is parallel to this chord. So what we need? Slope. So again first we have to differentiate, but the point is missing, so we assume that point is x1, y1. So at this point we draw, we find its slope. Then this point is on the curve, so it will satisfy the given curve. So we get one equation in y1 x1. Now tangent is parallel to this chord, so their slopes will be same. So after finding slope of chord, we equate both the slopes. Then we get value of x1. This x1 we can put in this equation to get y1. That will be our required point. Okay? So if any question is like this, you can proceed like this. Check. Question is, find the point on the curve y equal to x cube minus 11x plus 5 at which the tangent is y equal to x minus 11. Means what? At which point of this curve we have to draw tangent. So that equation will be y equal to x minus 11. At which point we draw tangent, so that its equation will be y equal to x minus 11. That point we need. Okay? So first let the point be P. Let the point be P. X1, y1 are coordinates. Then it is on the curve y equal to x cube minus 11x plus 5. So what? This point will satisfy this equation. So we get y1 equal to x1 cube minus 11x1 plus 5. Okay? Now we need values of x1 y1. For that we do work. Now we differentiate this one with respect to x. Why? To find slope of tangent. Then we get dy by dx, derivative of this 3x square minus 11. Okay? The slope of tangent at x1 y1 will be, say, m1, that will be 3x1 square minus 11. So this is slope of tangent, okay, of this curve at point P. But when we draw tangent at point P, then its equation will be y equal to x minus 11. Means it is also tangent. So its slope and its slope, this slope will be same only. Okay? We are drawing this tangent at point P only. And at P, slope of tangent is 3x1 square minus 11. So this slope will be same as slope of this line. Okay? So what do you write? Slope of tangent at P is equal to slope of line y equal to x minus 11. Okay? So slope of tangent at point P is 3x1 square minus 11, and its slope, so it is already in the form of y equal to mx plus c. That is y equal to mx plus c. And in class 11 you have seen how to find slope of a line, right? In the form of y equal to mx plus c, then coefficient of x is our slope. So here x coefficient is 1, so its slope is 1. So 3x1 square minus 11 equal to 1. Then it will give you 3x1 square equal to 12. Means x1 square equal to 4. And which gives x1 equal to plus minus 2. So values of x1 are 2 and minus 2. Now this value you put in equation 2. So if x1 is 2, what will happen? If x1 is 2, then y1 will be 2 cube minus 11 into 2 plus 5. So 22 minus 8 plus 5, 13. 22, 13. 9. So greater number negative. So y1 is minus 9. And if x1 is minus 2, then y1 equal to minus 2 cube minus 11 to minus 2 plus 5. So it is equal to 22. That is minus 8 plus 3 minus 3 and 22, 19. Positive 19. So your 2 points are -2 minus 9 and minus 2, 19. So at these 2 points, if we draw tangents, then it will be equal to this one. But these points are on this curve. So if we put this point in this equation, what will happen? y1 is y is minus 9, x is 2. So 2 minus 11 is minus 9, that is y minus 9. So this point, set on this equation. If we take minus 2 and 19, 19 minus 11 is 8. And here we get minus 2. It means this point does not satisfy this equation. And we are drawing tangent at these points. It means these points must satisfy this equation. So these are the points at which if we draw tangent, it will be equal to slope of this tangent 1. But this tangent cannot be at point minus 2, 19. If we draw tangent at this point, it will not be y equal to x minus 11. So this point only satisfies this equation. So since minus 2, 19 does not satisfy, so it does not satisfy y equal to x minus 11. So thus the required point is only 1, 2 minus 9. If we draw tangent at this point 2 minus 9, then only we get equation y equal to x minus 11. So if we get 2 points or more than 2 points, you have to find out some points can be rejected. Okay? So if at this point, if we draw tangent of this curve, then it will be y equal to x minus 11. Okay? Now, we have to find equation of tangent and normal of this curve at point 1, 3. Now we need equation of tangent of this curve at point 1, 3. So equation of line at 1.13. So point we have, only we need its slope. So how to find slope? Just find dy by dx. So given curve is y equal to x to the 4 minus 6x cube plus 13x square minus 10x plus 5. We need slope of tangent at this point. Then we can find equation of tangent easily. So differentiating y respect to x, we get dy by dx equal to 4x cube minus 18x square plus 26x minus 10. Okay? So slope of tangent at 0.13 will be is suppose m1. So dy by dx at 1,3. Value of dy by dx at 1,3. So 1,3. So here this contain only x. So just replace x by 1. We get 4 into 1 cube minus 18 into 1 square plus 26 into 1 minus 10. So 26 plus 4, 30, and this minus 28. So 30 minus 28, 2. So m1 is 2. Well, dy by dx at 1,3 is 2. So slope of tangent is 2. So slope of normal will be at 1 3 will be m2, and that is minus 1 upon dy by dx, means minus 1 upon 2. Okay, slope of normal is minus 1 by 2, slope of tangent is 2. Now equation of tangent normal. The equation of tangent at point 1 3 will be y minus y1, that is 3 in a point slope form. Y minus y1 is equal to slope, and slope now tangent is 2. So it is equal to 2 into x minus x1 is 1. So y minus 3 equal to 2x minus 2. That will give you 2x, y negative, then minus will come, then we get plus 1. The 2x minus y plus 1 equal to 0 is our equation of tangent. Then equation of normal at 1 3 will be y minus y1 is equal to slope. So its slope is minus 1 by 2 is into x minus x1. So it will give 2y minus 6 equal to minus x plus 1, which is x plus 2y minus 7 equal to 0. So this is equation of tangent. So if you want to find equation of tangent or normal at particular point, so just find derivative at that point and apply point slope form. Okay? Now question is, find the equation of lines, all lines having slope minus 1 that are tangents to the curve y equal to 1 upon x minus 1, where x is not 1. We have to find equation of lines. We need some lines which are having slope minus 1, and that should be tangents to the circle. This to curve. Okay? Slope should be minus 1 and that should be tangent of this curve. There are many lines which can have slope minus 1. Okay, all lines are parallel, suppose, so their slopes will be same. So suppose its slope is minus 1, its slope is minus 1, its slope minus 1. So many lines can be having slope minus 1, but that should be tangent to this curve. So to find equation of a line, we need slope and its one point. So point is missing here, so we assume one point. So let P x1 y1 be the point of contact of whose, of this line, point of contact of line whose slope is with slope minus 1, which touches the curve y equal to 1 upon x minus 1. Okay, means one line touches the circle, touches the curve at point x1 y1 and its slope is minus 1. Okay, so now we find, suppose this one is y equal to 1 upon x minus 1. Now we differentiate equation 1 with respect to x. Then we get dy by dx. Now this derivative will be, you can write this x minus 1 to the power minus 1, and it can be written x minus 1 to the power minus 1. Now if we differentiate this, we get a minus 1 into x minus 1 to the power minus 2, and again differentiate this, we get 1. It means it is minus 1 upon x minus 1 square. Okay? So slope of tangent at point x1 y1 and at P will be, say, m1 1 upon dy by dx at x1 y1. So it is equal to minus 1 upon x1 minus 1 whole square. Okay? We express by x1. But slope of tan lines are given minus 1. But slope of line is minus 1. It means minus 1 upon x minus 1 square is same as minus 1. Both will be same. Both are slopes of line. So it will give you x minus 1 square is equal to 1, which gives x1 minus 1 is equal to plus minus 1. ठीक है, x1 minus 1 equal to plus minus 1. So it will give you x1 equal to, when you take plus, you get 2. When you take minus 1, you get 0. ठीक है, when plus 1, then you get plus 2. When you get minus 1, you get 0. So x1 is 2 and 0. Now since this point P is on this curve, so it will settle this equation. So what we have? P x1 y1 is on 1. Therefore y1 is equal to 1 upon x1 minus 1. Now it is equation 2. Now when x1 is 2, what is our y1? If x1 is 2, then y1 will be 1 upon 2 minus 1, means 1 only. If x1 is 0, then y1 will be 1 upon minus 1, means minus 1. ठीक है? So we have 2 points. Our point is 2, 1 and 0 minus 1. So our points are 2, 1 and 0 minus 1. So at these 2 points, we can find equation of tangent. If you find equation of tangent at these 2 points, then their slope will be minus 1. Now equation of tangent at 2, 1 will be y minus y1, that is 1, is equal to slope, and slope is given minus 1 into x minus x1, 2. So minus x will come here, then plus x plus y, and plus 2 will come here. So x plus y minus 3 equal to 0 is 1 tangent. Then other tangent, equation of tangent at 0 minus 1 will be y minus y1. So y plus 1 equal to slope again minus 1 into x minus 0. So minus x will come here, x plus y plus 1 equal to 0. So equation of lines having slope minus 1 and which touches this circle, this curve, will be x plus y minus 3 equal to 0 and x plus y plus 1 equal to 0. These are our 2 required lines.